Okay, question 8. So, in this question, solutions based entirely on graphical numerical methods are not acceptable. In other words, we have to solve this using charts or graphs or purely non-calculator based work. Okay, anyway, let's have a look at this. So solve for the given angle range, which is in degrees by the way, so set your calculator into degree mode, for the given equation, which is 4 cos x plus 70 equals 3. Now to do this one, firstly, let's just make cos and everything inside the subject, so just divide 4 across. So I got something like this. I got cos x plus 70 equals 3/4, and then finally cos inverse to get a solution. Now to solve for x, you can easily get one solution now. However, if you notice here, and if you subtract 70, you're going to get a negative answer. And the problem with this result is that it does not fit the valid solution of x being bigger than 0 and less than 360. The value of x here, once you solve it, will be outside the interval. Now to get all other solutions, we have to use something known as a cast diagram, okay? So before I even take that step and find x, let's just work with 41.4. Every time you cos inverses, yeah, give this another name, like, I don't know, y, yeah? Like y. So therefore y equals 41.4. And now, to use the cast diagram, so you write CAST. When you're working with cos, we're going to use C, because the answer is positive and we work to positive values, we're going to put an angle here for C and a line here for A, and call these both angle Y. Now, A stands for all, so this means always positive. And C here stands for cos, because we're working with cos. And again, S and T are sine and tan. Now, to find all solutions, all you simply have to do is just realize that this is the pivot. So this is 0 degrees or 360 and so on. And then we just travel upwards. So let's do this as we go. So to get the first pair of solutions, we can see that we can go this way around to get, and this is an angle of y of 41.4, or we can go down here, and this is an angle going downwards of minus 41.4. Because remember, when you go below 0, it's negative. When you go upwards, it's positive. So think of it that way, yeah? So this way is in the positive direction, and this way is in the negative direction. Because all our solutions are positive, we need to always go around, yeah? So to get additional solutions, all we do is start here and then we do a full circle until we hit the next blue line, which is here. And you'll notice that it's almost a complete circle, but just y degrees less. So in other words, 360 less 41.4. And if you do another one, so let me change the color pen. If we go all the way around, you can see you can go past 360 and then hit the next blue line, which is a whole circle plus y, or 360 plus 41.4. And then you'll realize that you can do this multiple times. So if you do another solution, say let's do it twice here. Let's go past the next line. So if we go past the first blue lines and then do another loop, you'll see that we've done almost 2 circles, but y degrees less. So that'll be 720 minus 41.4. And again, 720 plus. So you can see it's always going to be in series of 360 times 360s or 720s and so on. Anyway, so that's all the possible solutions for y. So we have a bunch of solutions. However, to find x, now we need to use all of this and subtract them all by 70. So my guess is always start from the top. So let's use the plus value. So 41.4 minus 70 will give us a negative. If we start with minus, again, that's negative. So this first solution is invalid. So using 360. So I'm going to use the plus first, yeah? So if you do 360 plus 41.4 minus 70, you should get an x value of 331. And yes, that's within the 0 to 360. If I use the negative value here, you do 360 minus 41.4 and then minus 70 to find x, and you should get 248.6. Now, if you do the same for 720, you'll realize you get solutions bigger than 360. So the only 2 solutions are these, and that's it. So that's literally how you use a cast diagram in a very straightforward manner. Okay, now let's look at part 2. So part 2. So find for theta between 0 and 2 pi. So now we're working in radians, yeah? So again, shift your calculator into radian mode, okay, because you're working in pi forms. All the solutions of the given trig equation. Now, one thing I want to note here as well. So when you're working with cos squared or sine squared and so on, have a look at the entire equation and see what you can find more of. In this one, you can see that this is mainly dominated by sines. Now one cool trick about sine squared and cos squared is that you can use the standard trig formula, which is sine squared theta plus cos squared theta equals 1. And my tip is to always rewrite all of this in either fully sines or fully cos. Because you've got more sines, it's advisable to change cos squared here into something with sine squared. So looking at the general, popular equation, make cos squared the subject here, so you should get cos squared theta equals 1 minus sine squared theta. So just rearrange. And then substitute all of this one for cos squared. So anyway, let's have a look, yeah? So for part 2, it's over here. So again, notice that, make cos squared subject, and then replace cos squared theta here, so you get 1 minus sine squared. Expand the bracket, so you get 6 minus 6 sine squared theta. And then realize now that you can actually form some kind of quadratic equation, yeah? So what I did here, I just pretty much added 6 sine squared. I did 6 take away 5, which is 1, and then actually I left it there, and then plus it across. No wait, 6 take away 5 is 1, then subtract across, so you get minus 1, and you still got sine theta. So in other words, throw everything here on the right hand side, and you should get something like this, a nice quadratic equation. And now from here, just say, to solve this directly, just think of this as, I don't know, 12y squared plus y minus 1. So think of this one as y. Using the standard formula, replace your a, b, and c values. So in this case, a here would be 12, so a is 12, b here is 1, and c here is minus 1. Okay, and then plug into the formula, and you should get something like this. So sine theta is a quarter, or sine theta is minus a third. Now, and then when you sine inverse both of these, you should get 2 solutions. Now, what you could do here, you could use a cast diagram, but I'm going to go ahead and use the actual sine wave, because the reason why is that when you have a negative solutions, you have to realize that using the cast diagram, we cannot use S anymore. We'd have to use the other layers, T and C. And to avoid that confusion, I think it's best to use the sine, the actual wave. Okay? And that's it. And now all you do is literally just draw a line cutting through quarter here, which is 1/4. And you draw another line cutting through minus a third, which is over here. And just draw it all the way across until you cut up to 2 pi degrees. So here's 2 pi, here's pi, and then you just draw lines. Now, to find valid solutions, you can see that up to a quarter, we had 0.253. This means that at this point, the solution was 2.53. And same for this one. It says theta was minus 0.34. So in other words, minus 0.34 is on the left side. This part here was minus 0.34. This means on the right hand side, if you continue through this line, you'll find that this solution here would be pi plus 0.34. And if you carry on across, and here, if this is 2 pi, this is 0.34 less than 2 pi, so 2 pi minus 0.34. So these are a couple solutions you can use. For the quarter value, again, the quarter value is 0.253, and if pi is over here, if you just draw a little dotted line from here, you'll realize that this value is just a bit less than pi, so it's pi minus 0.253. And if you were to carry on, I mean, you won't get another solution, because then this one cuts over here. So your next solution would be like something like 2 pi plus, and then that would be out of the range. So yeah, so your final solutions here would therefore be this solution here, because it's in the range, not this one. This solution here, because it's in the range, this solution, and finally this solution. And oh yeah, sorry. And here is your final solution. So smashing this in the calculator, you got 2.53 there. Pi minus 0.53 should give us 2.89. Pi plus 0.34 should give us 3.48. And finally, 2 pi minus this value should give us 5.94. Done. And yeah, keep all your answers to 3 significant figures, because that's what they wanted, yeah? And that's all. So yeah, if you enjoyed this video, give me a like, subscribe, share with your friends. Otherwise, catch you in the final one. Ciao.